In our last example, example 7, we have y equals 1 plus sine, and the input is 1/2 x minus pi over 4. Once again, let's compare this to the general equation. Y equals c plus a times sine bracket b times x minus d bracket. So what we have is a vertical shift. We're adding a value on the outside of our function, so the vertical shift will be positive 1, which means the new middle of our graph will be at y equals 1. The amplitude, we have not multiplied anything times the front of the function. It's an implied 1. So the amplitude is 1. The phase shift. We mentioned earlier in example 6 that we want to be careful about saying that our phase shift is minus pi over 4. We want to be careful about that because the general form of the formula, b is the period, we want to factor out the period. We don't want it to be multiplied or distributed into the parentheses. Right now, the period has been multiplied in times the d. So what we actually have here is b times d. Well, we want to know what d is. We want to know the phase shift. So since we have parentheses there and not a bracket in parentheses, we are going to factor out or divide out by 1/2. That way we can separate the period and the phase shift. Now if I divide by 1/2, let's rewrite our function. Y equals 1 plus sine bracket 1/2, and then we're going to put in x, because 1/2 times 1/2 just leaves us with x, and 1/2 divided into pi over 4. Well, we're going to flip the bottom fraction, change to multiplication, cancel common factors, minus pi over 2. Notice that if I multiply 1/2 times x, we get back 1/2 x, the original input, and 1/2 times pi over 2, we get back minus pi over 4. So the phase shift is actually positive pi over 2. Remember, phase shift happens in the opposite direction of the sine. And the period, well, the b is now 1/2. Be careful though, the period is 2 pi divided by b. So that's 2 pi divided by 1/2. Flip the bottom fraction, change to multiplication. The period then is 4 pi. Now let's take the input of our function and put it in between 0 and 2 pi. So we're going to take the whole, everything that's in the brackets here, and we're going to put it in between 0 and 2 pi. Now to get rid of this 1/2, we can multiply by the reciprocal, so I can multiply everything through by 2. 2 times 0 is 0. 2 times 1/2 is just 1. So we end up getting 1 times x minus pi over 2, which is just x minus pi over 2. And then 2 times 2 is 4, so we have 4 pi. And then add pi over 2 to all three parts. So our graph will start at pi over 2. And the x value that we will end with, we have to give this the common denominator, multiply top and the bottom by 2. 8 pi over 2 plus pi over 2 would be 9 pi over 2. So now when we go to graph, we know that we need to find all of our x values. We know the graphs. So our graph will start at pi over 2, end at 9 pi over 2. Finding midpoints, add together, multiply by 1/2. We reduce our fraction, we find that the x value at the middle will be 5 pi over 2. 5 pi over 2 plus pi over 2 would be 6 pi over 2. Multiply by 1/2. Reduce our fraction. We get 3 pi over 2. 5 pi over 2 plus 9 pi over 2 is 14 pi over 2. Multiply by a half. Reduce our fraction, and we get 7 pi over 2. So those are our three midpoints. So now we have 4 equal segments of our graph, and we said that the vertical shift was y equals 1, so we went up 1 unit. So the new middle of our graph will be at y equals 1. The amplitude is 1. We don't have a vertical flip, so we're just going to graph our sine function in the usual manner. So we're going to start at pi over 2. At the second point we're up at 2, so at 3 pi over 2 we go up from the middle 1 unit because our amplitude is 1, so up 1 unit from the middle. At the third point we're back to the middle of our graph. At the fourth point we go down 1 unit from the middle to get to our minimum point, and then at the fifth point we are back up to the middle. Draw in our sine curve through those 5 points.